pushdown automaton are non-deterministic. In our finite automaton, there are two types of finite automaton, non-deterministic finite automaton is there. That means for Q, A, Z. That means delta of Q, A, Z is a singleton. That means if you have a single transition for this, then that is deterministic. Otherwise it is not. Suppose that you have two transitions for this, then that is non-deterministic. For example, I will show you another example. Suppose that WCW, instead of WCW raised to R, suppose that you are having WW raised to R. WW raised to R means a string followed by the reversal of the string. A string followed by the reversal of the string. See, suppose that you have 0, 0, 1, 1, 0, 0. See, if you are treating this as W and this as W raised to R, then that will be accepted. But the finite control does not know. That means it is not in a position to know the middle element. Here, this is the middle. And as you are having WCW raised to R, here we have a mechanism for finding the middle of that. That means up to that C you have W, and after that you have that W in the reversed form. But here in this case, if you have W raised to R, a string followed by the reversal of the string, what will happen? This we are not in a position. That means suppose that you have a string like this. After reading each symbol, that means after reading this one, the finite control is expecting this as W and the remaining as WR. After this point also, it is expecting this as W and this is W raised to R. And after this point also, it is expecting this as W and this as W raised to R and likewise. Okay, that means there is no mechanism for checking the middle or finding out where this W ends and where W raised to R starts. So for that, we are going to design a non-deterministic finite automaton for this. Non-deterministic finite automaton. Okay, see, one thing you should remember, that means here 0, 0, 1, 1, 0, 0. That means W, if W raised to R is there, that means the last element of W should be the first element of W raised to R. That means if you have a string which is if your W is ending in 0, then W raised to R should start with 0. And if your W is ending with 1, and W raised to R should also starts with 1. That means if you have such a combination 0, 0 and 1, 1, there we are expecting the end of W. But if you have a 0, 1, that means if it is 0 and 1, that means this is not a terminating point of W. Why? W raised to R should start with 0 if this is W and this is W raised to R. But if you have such a 0, 1 combination, or here this is W and this is W raised to R, not possible. Why? Here this is ending with 0, and if this is W raised to R, here this should start with 0. Or here also we don't have such thing, because if you have W here and you have W raised to R here, if W is terminating this one, and W raised to R should also start with 1. So if you have a 0, 0 or 1, 1 combination, there you are expecting W to end. Okay, so for that we are going to have a non-deterministic finite automaton, non-deterministic pushdown automaton for that, and I am going to write the transition for this. That means this is the same. That means if you are encountering a blue plate, if here you don't have any C, that means here you are not having any C. Here you are not having any C. You have only zeros and ones. Here you are having only zeros and ones, and at any point in time this W can terminate and start W raised to R. But there is no mechanism for finding out that. So we are going for a non-deterministic finite automaton for accepting the language W raised to R. Here this is L is equal to W raised to R, where W is an element of 0, 1 star. Here, okay. See, now I am going to write the transition for this. That means that if there is a blue plate, if there encounters a blue plate, what will happen? If the current top of the stack is red, and if there encounters a blue plate or a red plate, then if it is a blue plate, we can. If it is not a blue plate, if there encounters a 0, we can add a. Definitely, you can add a blue plate, and if there encounters a 1 in the input, then definitely you can add a green plate. That means delta of Q1 0 R, red is on top, and next input is 0, and the current state is Q1. You are staying in the same state Q1, and you are going to add a blue plate, that is BR. And delta of Q1 1R, that means if the next input is 1, and if the current of the state is having R, definitely you have Q1 and green red. That means you have pushed the green onto the stack, green plate onto the stack. Now suppose that you have delta of, now the transitions for red is over. If it is in state Q1, and if it is a 0, it is adding a blue plate. If it is a 1, you are adding a green plate. Okay. Now suppose that you are in state Q1 and you are in state 0, and if blue is on top, definitely if it is a deterministic finite automaton, as I told you earlier, if you have a transition from 0 to 0, B is on top means the last symbol you have read is 0, and the next input is also 0. That is the meaning. In between, this W can terminate. In between, this W can terminate. If this W is terminated, here after this point onwards, you have to verify whether this is W raised to R. That means, as I told you earlier, for this W raised to R, you are going to design a non-deterministic finite automaton. Why? Here there is no mechanism to find out the middle. That means where does this W terminate, and the starting of W raised to R, there is no mechanism to find out that. For this, we are going to have a non-deterministic finite automaton. In the sense, that means after, if there is a 0 to 0 transition or 1 to 1 transition, what will happen? The finite control is expecting the end of W here and the starting of the reversed W from that point onwards. And we are expecting, and in that case, it is splitting into two directions. It is going in two directions, and one is it is expecting the end of W, and the other control is not expecting the end of W. That means at that point, in this case, at that point, what the finite control does is, it is expecting one control is expecting the end of W and the other control is not expecting the end of W. At this point is diverting in two directions. So here at this point, if B on top means the last input symbol you have read is 0 and the next input is also 0, what will happen? Suppose that here this is you are having two transitions, and first transition is it is not expecting them, that means here 0 to 0 transition, from 0 to 0 you are treating this whole as a part of W, that means you are not expecting this as the end of W. This is the first case and this is the second case. In the first case, you are not expecting the end of W, so again you are going to push this, again staying in the same state Q1, and you are pushing a blue element or you are pushing a blue plate. That means it is not the end of W, and expecting that it is not the end of the end of W, it is pushing that blue, and a replica of your stack is again created, and in that you are expecting the end of W. If this is the end of W, what will happen? For this W, suppose that this is the end of W and this is the starting, this is W and this is the starting of W raised to R, what will happen? After reading or after processing this element, the finite control pushed blow onto the stack, and after encountering this, that means if you are expecting this as the terminating point of W, then when encountering this 0, what will happen? It has to pop that element. It has to pop that element from the stack. Okay, here in that case, you are switching to a new state. For processing W raised to R, you have to switch to a new state Q2 after removing this flag. That means you are popping that element from the stack. That means here Q2 epsilon. This is epsilon means you have popped on an element from the stack. That means current top of the stack is having current top of the stack. That means the top of the stack, that blue plate you have removed. Okay. Now this is in state Q1. Now this is delta of Q1, 1 and green. Suppose that here you have 1 and 1, and suppose that here there is a transition from 1 to 1, what will happen? Again, there are two possibilities. It is staying in the same state and you are pushing a green plate, green, and next is suppose that this is the end of W and this is the start of W raised to R, you have pop that green, in that case Q2 epsilon. Okay, now other transitions are delta of Q1 0 and green, definitely you can push that element on the stack. That means blue can be pushed on the stack, staying in the same state. That means Q1 staying in the same state, blue green, and delta of Q1 1 blue plate is on top and the next input is 1, can easily push green plate on the stack. That means GB. Okay. Now red, blue, green. Now 6 transitions. And Other transitions are delta of Q2 0 blue. That means current top is having blue and the next input is 0. We can pop the element. That means staying in the same state Q2 epsilon. Delta of Q2 1 green. What will happen? Again, this is Q2 epsilon. That means 0 and blue, that element is popped. 1 and green, that element also is popped. And this is an example of a non-deterministic finite automata. So when you are processing the input, for example, suppose that we have using this, I am going to process this, and for convenience, I am going to beat off. Suppose that I have the input, say 0, 0, 1, 1, 0, 0. Suppose that this is the input, and initially the finite control is in state Q1, and see, I am going to define this like this. Q1 is the Q1, and the instantaneous description of this is Q1 0, 0, 0, 0 and front. That means here Q1 is the current state of the finite control, and the input is 0, 0, 1, 1, 0, 0, and this is red. The next input is red. And in a single move, Q1 after reading 0, and if red is on top, what will happen? Q1 on 0, and if red is on top, we are going to push this B. That means in a single transition, Q1 is, that means it is moving to the next, that means 0, 1, 1, 0, 0, and this is represented by BR. That means you have pushed blue into the stack. Why? You have processed single 0, and after that the rest is this one. That means that you have written here, and which is the next state is again Q1 on 0. What will happen? This is Q1 on 0. What will happen? Q1 on 0. And if blue is on top, Q1 on 0, if blue is on top, now you have two possibilities. Either you can add a blue plate or you can remove a blue plate. Either you can add a blue plate or you can remove a blue plate. That means there are two possibilities. That means here you have two possibilities. One possibility is you are adding a blue plate. That means here Q1 0B. Q1 is the current state, 0 is the next input, and blue is on top. And in that case you have two possibilities. Now those two possibilities are Q1 BB. That means you are pushing that blue element, or you can pop that B. That means here, see that in this case you are taking the first one. That means is staying in the same state Q1. You have removed or you are adding a blue plate, and you are moving to the next input symbol. That means 1, 1, 0, 0. That is the next input symbol. And now you have pushed B. Now this becomes B, B, R. Okay. That means after processing two zeros, now you have two blue plates, and the rest is 1, 1, 0, 0. And at this point, can have, that means you do not know whether 0 followed by 0, that means this in between this 0 and 0, the W terminates. So what will happen? When processing that 0, it is taking the other chance also. That is why you have Q2 epsilon. That means that is doing this, that means it is switching to state Q0 and you are removing this B, that means 1100 and red. So you already know that once you have the bottom of the stack marker in this, you have to empty the stack. You have to, no more processing is possible right now. From this point onwards, you don't have to, there is no need to process this. That means up to this, that means Q2 on R. That means without waiting for the next input, you can terminate. That means if Q2 is in state Q2, it is popping elements. It is popping elements. It is not going to push any elements. Okay. So in this state Q2, if there happens or if the bottom of the top of the stack is having red, then without waiting for the input, you have to terminate. That's the condition. That means this is terminated, or at this point it has terminated without waiting for input. Now one valid one is this one, and now you're going to have next one is, say it is in state Q1 and it is reading 1 and the current out is having blue. That means Q1 1B, what will happen? Q1 1B, what will happen? It is pushing or it is adding a green plate. That means GB. It is staying the same state Q1 and adding G. That means this is the next state is Q1 and advancing to the next input symbol after G B B R means you have added a green plate, and that move is also deterministic by it is not having multiple transitions. That means now what will happen? Q1 on 1 and green is Q1 1G. Q1 1G, you have two directions. One direction is Q1 1G in this direction and the other is this direction. That means it is either going to add a green plate or it is removing a green plate. So we are going to have two. That means first case is we are going to add a green plate, and in this case Q1, and we are advancing the next input symbol after adding GGBBR. Okay. Now the second route is like this. That means it is removing a green plate, removing from this a green plate and advancing. That means in that case this will become Q1 00 BBR. Okay. That means now see Q1 0 green, Q1 0 green, Q1 0 green means it is adding blue and green. That means this is staying the same state Q1, advancing to the next symbol. We have added blue, green, green, blue, blue, red, and the next step Q1 0B. What is Q1 0B? Q1 0B, that is it is either adding blue or it's removing blue. That means here first route is you are adding this blue, then see here you have staying in the same state Q1 and you have consumed all the inputs B, B, G, G, B, B, R. That means after consuming all the inputs, this is not empty, so this is not, that means stack is not empty, so not accepted. Okay. Now from this you have take the second route. That means you are removing this blank symbol or blue symbol, and now you are going to have Q1. That means move it to the next input. That means you have consumed all the inputs, and what you have popped this blue plate, and what remains is GGBBR. That means in this case also stack is not empty, stack not empty, not accepted. If it has to accept, then after consuming all the inputs, stack should be empty. See, at this point, suppose that Q21100R, that means if in state Q2 you are popping elements, in state Q2 you are popping elements, and once you have reached the bottom of the stack and without waiting for the input you have to terminate. Here it is just terminated without accepting. In that case also it has failed. Now what about this route? Q100BB right. That means Q10 blank. What will happen? Q10 blank. Either you have to add a blue plate or you have to remove the blue plate. Either you have, that means here from this point onwards it is taking two routes, and that means this is route number 1. In route number 1, what you are going to do is you are adding blue plate. That means it is staying in the same state Q1 and advancing to the next input. What remains in the input is only a single zero, and we have added a blue plate. That means B, 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 R. Okay. Now, in the next stage, Q10 blank, what will happen? Q10 blank. It is again taking two directions. Is taking two directions. That means from this point onwards, it is taking two directions. It is either adding 0 or blue plate, or that means suppose that this is the first row, it is adding a blue plate, that means this will become Q1, your stack is empty or your input is empty, then B, 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 R. That means here stack is not empty, stack not empty. So not accepted. It is not accepting anything. Not accepted. Okay. If you are taking this route, what will happen? That means here 0, 0 and blank. That means you are popping a B. That means you are popping a blank and switches to state Q2. That means here this is in state Q2 and you are advancing to the next input symbol, means all the inputs have been consumed, and what remains B, B, R. In this case also stack is not empty, so not accepted. This also not accepted. What about this? Q101 blank. What will happen? Q101 blank means Q101 blank. There are two possibilities. Either you can push a blank or you can pop a blank. That means first case you are pushing. Pushing a blank. That means this will become Q1 0 B B B R. Okay. BBBR, and the rest I am going to write here. That means Q101B, what will happen? It is taking again two directions. That means Q10B. Q10B, it is again taking two directions. It is either adding a B or popping. See, this is the current stack. If you are adding a blank or removing a blue plate, if you are adding a blue plate or removing a blue plate, in both the cases, after consuming all the input, the stack is not empty, so that is not accepted. See, after this move, suppose that you are taking the next the other option. That means you are popping. This will become Q1. You are advancing to the next input symbol 0 after popping this. That means now BR. And now Q10B, again it has two options. First one is you are adding. That means after consuming all the inputs, if you are adding this B, that is the first case. In that case, the stack is not empty, so that is not accepted. And if you are removing this blank, what will happen? Then this will become Q1 after this This is red. That means after considering all the inputs, you have reached the bottom of the stack, and at this point you have emptied the stack. That means upon considering all the inputs, you have reached the end of the stack. So that is accepted. That means this is the way. That means this is non-deterministic pushdown automaton, and all pushdown automatons are non-deterministic. That means you are going in different directions, and if any one of that can be accepted, then that pushdown automaton is successfully accepting that string. So with this, I am concluding the session. Anyway, I am going to note that you should note that all PDAs are non-deterministic. All pushdown automata are non-deterministic, and by default, if you are writing PDA, it is non-deterministic. If you want a deterministic finite automaton, you have to specifically or you have to intentionally write DPDA, deterministic pushdown automaton. Unless you write, if you are writing PDA, that means it is not deterministic PDA. And the class of language is accepted by a DPDA is like this, or this is the language accepted by a PDA. Then DPDA is accepting only a subset of that. This is DPDA. And this is regular. Regular is again a subset of DPDA. And this is the Venn diagram which is used to represent the class of languages accepted by pushdown automaton. And so all deterministic pushdown automaton are non-deterministic, but all non-deterministic automaton is not equivalent to DPDA. That means DPDA and NPDA are not equivalent. That means DPDA is only accepting a portion or subset of the languages represented by a PDA. So with that, I am concluding this session, and thank you. Have a nice day.